Hello, good afternoon, everybody. I'm George Nounesis. I'm the director of Demokritos, the National Center for Scientific Research of Greece, and I'm very happy to welcome you here at the campus for this very interesting, very exciting summer school. On behalf of Dr. Vangelis Karkaletsis, the director of the Institute of Informatics and Telecommunications of Demokritos, who is actually flying to Ireland as we speak, it is indeed my very, very great pleasure to introduce to you today's keynote speaker. He is a very good friend of mine, so I'm particularly happy to introduce him, Professor Ioannidis. He is a professor at the Department of Informatics and Telecommunications of the National and Kapodistrian University of Athens. That's the biggest university of Greece. And he is also associate faculty at the Athena, the Research and Innovation Center. At Athena, he was a president for 10 years. And indeed, this is how I got to meet him and to collaborate with him. And indeed, I had a great time, basically, plotting the strategy of the national strategy of Greece for research and innovation these last few years. As I said before, he is still an associate faculty at Athena, and I don't think he will ever leave Athena. It's his great love, and he did an incredibly good work at this research center, one of the very, very competitive research centers of Greece. I would say more competitive than Demokritos as well. So he has a well-known recognition, many awards, fellowships at the ACM and IEEE, and many prestigious awards. The most important thing that I need to say is that since last July, he's been elected as president of ACM. I think this is the first time a Greek guy gets to this job. It's very rare for any nationality, actually, to get to this job. And I wish him all the best and great luck. And if you don't have a membership at ACM, you can arrange that you will do that. So I think today's talk it's on open science and open data, which the last few years that I follow him and I collaborate with him, this is indeed his great interest and great love. So once again, thank you for being at Demokritos, and I give the floor to Professor Ioannidis. Thank you.
Thank you very much. It's a great pleasure to be here, and as the president of Demokritos said, we're very good friends, very good collaboration. It's the work that brought us together, but now it's a much broader interactions that we have on a personal and professional level. Before I start, I have a request for all of you. Please stand and walk down about 10 steps. And come close to me, and it's a huge room. You chose all to sit at the very furthest away from me, and I feel, like in a totalitarian regime. So please come here. I don't bite. Nobody bites here. Yeah, I mean, the first 5, 6 rows. I mean, you shouldn't be one on top of the other, but please come closer. Because of the camera, I won't be able to move much. So, don't be afraid. Even if you want to leave, you can leave from the first row. I will not be offended. Okay, that's not ideal, but much improvement. Thank you very much. Okay, so as it was said in my introduction, I'm a professor at the University of Athens at the Athena Research Center, but I have an affiliation of OpenAIRE. I will talk about OpenAIRE, and you can understand open is related to open science, which is the main topic of my presentation. So we'll You'll see OpenAIRE is a not-for-profit international organization headquartered in Athens, and I am the legal representative for that. So let's see. An overview of what I will talk about. Open science. A few glimpses of, since this is a data science on climate modeling summer school, I'll say a few things of how open science has been related to climate or environment or more general things. I will talk about the European Open Science Cloud, which is a European effort for open science, a general infrastructure for this. OpenAIRE, which is what, as you saw, my other nonprofit affiliation for open science. And there are useful services. I won't talk about them. I have them a slide. I don't know if the slides will be shared with you. I'll send a version, and but they will be there. So, open science, why, what, who? Question, how many of you know what open science is? Okay. How many of you have heard of the term open science? Okay, a third. How many of you have heard of the term open access? Okay, 2/3. Okay, getting there. Good. So today you'll get a very first tutorial, a horizontal tutorial about open science, open access, and so on and so forth. And then when you go off, you'll be called to apply it, you know, in your professional life, in your research life, in your scientific life. So why are we talking about open science? Well, these are the largest private publishers: Elsevier, Springer, Wiley, and there are a whole bunch of others. And the total market for these publishers, I mean, I should ask, and you can tell, and yes, anyway, let's make it, it's about 10 billion. $10 billion, euros these days doesn't really matter. It's more or less one-to-one. $10 billion are paid by you as individuals, research centers, universities, and so on, to the scientific publishing industry. That's a lot of money. You can do a lot of good with 10 billion. And the cost, these are for profit. The cost is much less. So can we do it for much less and have the same scientific output this way? Well, and it's also double dipping. And double dipping in the sense of many pay to produce and many pay to read as well. So this is an issue. And since the early 2000s, there has been the open access movement and then generalized open science. The other one is impact factor. How many of you have heard of the term impact factor? Okay. You see, for the useless things, we know more of. Impact factor is a legitimate but very poor attempt to capture the impact of a research publication. I won't go into the definition. Someone, you know, one day woke up, had smoked a few things the night before, and then they said, okay, we will come up with this definition for impact factor. And there are a whole bunch of numbers. You know, 73% of the journals, I'm not talking about conferences here, impact factor is only for journals, have an impact factor more than 1. And then 42% more than 2, blah, 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 blah. The thing is that often this is a misused metric. And you can misuse it on purpose, but also it can be misused as the quality of a paper, even if the impact factor of a journal reflects something reasonable, not everything that is published in this journal is at the same level. And yet often we evaluate people, we evaluate organizations based on impact factors. And as I said, the definition is very ad hoc. And last but not least, it's all about publishing text with some pictures, static. the data that was used to come up with the results, the data that was produced, the data on the instruments that were used for all of this, the software that was used. Maybe it's mentioned, maybe it's not, but you don't have access to it. All you have access is text. So this is where the data is usually, and the text, the publication is the main thing. But open science, for these reasons, there are others, but these are the main reasons, is, by the way, by not having the data, you cannot validate output. A huge percentage, in medicine it is close to 65 to 67% of all published papers cannot be reproduced. And in various, I mean, there's a list of every discipline. So in climate modeling or environmental sciences, I don't know what the number is, computer science and so on. So this is a very big thing that we want to change. So what is open science? Rough definition is a new standard of practice in research and science. What the means that you use and how you collaborate for producing, I'll just read it because it's definition, and distributing scientific output and research results with a direct scientific, economic, and societal impact. So the societal impact, the reproducibility is very important. Notice that it doesn't say publication, it says output and research results. It's not just a publication. And the core principles are to collaborate, to have open access. If the taxpayer through governmental agencies has funded a research, then the results should be freely available to society because society paid for it. It's an issue of democracy, it's an issue of fairness. So open access. Now, I talked about fairness. There is also a very ingenious way of talking about fair, which means findable, accessible, interoperable, and reusable data, software. Everything should be able, you should be able to find it. You should be able to access it, not just find it, to interoperate with others and to use it. Just seeing a picture of a table on a piece of paper, you cannot reuse that. All you can do is maybe take a picture, but you cannot reuse the data. And of course, everything to be documented in a way so that it's transparent and accurate. And then you can see others, you can give the opportunity to others to reproduce it or not. And the areas where things are changing, one is the scientific output. As I said, it's not just the paper. It's the data, it's the software, it's the methodology, it's the protocol, it's the information about the instrument that was used, and so on. In order to do open science, you need infrastructures. Open science would not have been possible without computer science, without computing. It is the computing technology that is bringing the ability to do open science. We have lots of open data, we have lots of data, therefore, and the technology to support it and provide it and interconnect it. And you need infrastructures. Not everyone, I mean, everyone has a desk and they have a desktop on and has a disk. And they keep their private data of their private research, not private, of their research there. This does not allow for fairness, does not allow for open access, that it's difficult for collaboration and so on. You need infrastructures that support all this, the way we have the roads, to go from one place to the next. And then, since open science has a very different, is a different paradigm to science, to do research, all of us, scientists, researchers, need to be trained on how to do this. So these are the 3 points of action. So why in the more not looking at the bad things, but looking at the good things, we want the research so that democratization of scientific output, many more people to look at it, reuse the research results, reproducibility, and not lose data. Much data that has been produced in science is lost. You cannot go back. The researchers, open science keeps us on our toes, to be alert, to do correct research, because it will be open, it will be judged not just by a paper. You will actually rerun the experiment and so on. Economy. The more open data you have, it has been measured. Preliminary studies show that innovation is increasing whenever, as you open your research results, more and more people can combine things, can collaborate things, and then innovate and have startups and come up with the next idea. So innovation is accelerating. And then society. Society pays, okay, I mean, private companies also pay for their research, but let's talk about the publicly funded research. Society has paid for it. It's taxpayers' money that fund Demokritos, Athena, the University of Athens, and so on. Society has the right to know of what is the result and what impact does it have on its well-being. So trust to society, inclusivity, and then collaborations. You've heard about citizen scientists, meaning the 10-year-old that looks at the data that has come from that telescope and then finds a star. Well, definitely the 10-year-old is not a scientist, but it is what we call a citizen scientist. Okay, and by having data open, this gives the ability to anyone interested in science, even if they do something else, to have access to it. Some examples, advertising. When COVID-19 hit, it was the reaction of the scientific community was formidable, very fast. Immediately, even the private publishers, for a limited time, they opened up all publications. Some of them, all of their publications. Some of them, any publication that had was related to COVID-19. And many people say that, first of all, huge funding, and second of all, the openness of this data was what accelerated the development of the vaccines much faster than any other vaccine in the history of virology. So open science played a very big role, and also many infrastructures opened up like this. NASA has opened its data for Earth observation, for much data, and then people can check on whether Venice will flood or will drown in the flood or not. This is an announcement from CERN, high energy physics, new open data policy in support of open science. So all the NASA or the CERN data with a particular policy will be opened appropriately. And then these are various news from citizen scientists, your non-science person discoveries, finding things. It usually starts, but still. So open science, and I give you a bunch of examples that touch upon the 4 areas that I mentioned about society, about researchers, and so on. As I mentioned before, data is the center, is at center stage of open science. I mean, usually you ask for, you bring in data, you analyze it, you curate it. Physics data is an example of physics. You curate it, then you prepare the input in order to do machine learning. Here it says deep learning because it's the current buzzword, but it's any kind of machine learning. Then you develop the model by fine-tuning on the use data set, and then you train it to be able to use it. And you see data out. Open science cannot operate without taking care of the data that you're dealing with. Most science now, it is data-based science. Open science is taking advantage of that by opening the data and the publication and all the other things. Now, if I remember correctly in your program, there is quite a bit of machine learning in the modules that you had. Well, artificial intelligence, open science is go in some sense hand in hand. The European Commission is talking about fate in artificial intelligence, that it has to be fair in the sense of the word fair that we talk about, accountable, transparent, and ethical. And we can have summer schools in each one of these terms with respect to AI, but that's a different story. As a society, and especially as a scientific community, we have to make sure that we advance AI as fast as we can, but also as fairly, transparently, ethically, and so on. And on the other side, we have the fair and openness on data. This is about models. This is about data. I mentioned findable, accessible, interoperable, and reusable. And when it comes to artificial intelligence, this is a nice AI now permeates everything. There are low risk things like, I don't know, using AI to match people or to choose, what movie you'll see in the evening. And at the top, you have using AI to operate a nuclear power plant or to choose the right treatment. So all of these have very different levels of fateness that has to be done, and they come and interconnect with the fairness and openness of the data. And by the way, you can be, let me say two things about fair. Maybe data is fair, you can find it, you can access it, you can interoperate and you use it, but it's open is not necessarily fair. There are other things that have to deal with open and other things that have to do with fairness, because some fair data, like personal medical data, cannot be open. So the two terms, the two concepts interact. And the other thing is that you can have fair data that is completely garbage, because fair, there's no Q in fair. There's nothing about quality of the data. And of course, quality is very important to do our science. As I said, the holy grail of all science is reproducible science. Any research that you do, any results that you get, it must be reproducible. Someone else may be able to take it and take the same environment, take the same input, and come up with the same results. And if you have just a publication, this thing is not reproducible. And as I said, in most cases, not consciously, the great majority of publications are not reproducible. But then, as we can increase reproducibility, next to the publication, give also some code, open source, or even not open source, then code and data, and then linked and executable code and data. Then the entire environment where whatever experiment was run to be run, if it involves code. Here we should put instruments and other things that are applicable in different sciences. And then we get full replication. That's what we should be striving when we do our research, when we do our science, or when we do our, especially the data science. And this is the goal that comes from another publication of what is necessary in order to do open science, to reach this holy grail of all research to be reproducible. And by being reproducible, you're also accountable to your peers and you're accountable to society as well. Okay, open science, some scientists came up with a term. Has this caught on? Yes. Worldwide, there are policies about open science everywhere. This is, you cannot read the date, it says August 25, 2022. So 10 days ago, 11 days ago, this is the announcement from the White House in the US. Today, the White House Office of Science and Technology Policy updated the US policy, etc., etc. The mandate was already from Barack Obama's administration to move towards open access and open science. Now this announcement talks about lots and lots of zeros after a one in dollars that will be funded in order to support having all publicly funded data. Publications is much cheaper, but now data available openly in order to support open science. And the European Commission has been a leader. I believe that all of you are from Europe except one, right? Is there someone of you that is not from Europe? Okay, 2. Okay, good. 3. How many are you? You're not studying, you're not living, you're not working in Europe. 1. Okay. Not originally where you were born from, because I'm sure you're from all over the place. Okay. So there are a few more things about Europe, but whatever I say here, it's happening around the world. I'll be making some connections. So Europe has been the leader in terms of openness. I mean, the Berlin Declaration, first declaration for open access, was in Berlin, and Berlin is in Europe. It's mostly Europeans, and the European Commission was ahead in coming up with policies and mandates and so on and so forth. UNESCO, the United Nations, has 2 years ago issued its recommendations for the United Nations in terms of open access and open science for its terms, and actually emphasizing that open science is a big push in order to be able to implement the United Nations Sustainable Development Goals. I'll come to that towards the end of my talk. So, since this is a summer school for climate modeling, or data science for climate modeling, a few glimpses of, how it has been connected. There is the Open Climate Campaign. There are 3 or 4 organizations, primarily in Europe, but not necessarily, that are involved, and the website is here. You can go and check and see how people, how researchers, how the communities come together. I think it's Eiffel, Spark, and one more. I can't remember now the third one, that come together and build interactions and recommendations on how we can have in the community of climate science openness, and how we can apply the open science principles into climate. And they call it the Open Climate Campaign. It's very important initiative here. Also, every year in October, there is International Open Access Week. And this year it is October 24 to 30. And every year there is a theme. I mean, lots of things are being discussed around the world. This is international. And every year there is a theme. And this year the theme is open for climate justice. And you have to be open in order to help understand the differences, see the impacts that are happening, in order to study and be just with respect to how, as the world addresses the climate crisis. The rich nations have the biggest impact on the climate change, and the not so rich nations are feeling the consequences. So that's there, and then it's Open Access Week. NASA has an initiative to transform much of its data in a way that is reusable and so on and so forth. And it's called STOPS. It started this year, and it is an initiative to run until 2027 to bring open science, the communities and the sciences that are related to NASA, to bring them closer. And OpenAIRE, the nonprofit infrastructure that I mentioned, international, I'll say a few things later, comes up with gateways on particular data and software and publications for specific fields. And I'll just mention one, that is the ENERMAPS initiative on energy, marine science, and other things that have to do with environment. And well, let's skip that. Now, all this is the principle. This is the new paradigm of doing science. We are in Europe, so there is the thing that the European Commission and member states fund in order to support open science is something that is called the European Open Science Cloud. So the overall framework, you may have heard some of these terms, maybe not, but as I said, Europe has been looking into open science for a long time, and ERA is the European research area. This is all research in Europe is being operated at the pan-European level, not the national level, at under the concept of the European research area, issues of intellectual property rights, skills that people need to be reskilling, and so on and so forth. Well, the European Cloud Initiative, as part of that, comes the European Open Science Cloud. The vision is having an infrastructure where everyone can put their data, their publications, their software, everything that is an instrument, is a tool, is a means to do research, and everything that is produced from this to be able to be placed and supported under the European Open Science Cloud. Emphasis is on data, as I mentioned. Of course, this doesn't mean that there will be one place somewhere in Europe where all of this will be stored. To be highly distributed, and specific sciences, specific disciplines have their own things that they do in this direction. The European Open Science Cloud will harvest these thematic, national, everything that is happening at different levels to be united under the European Open Science Cloud, which with additional resources will be able to do this. I won't read all the vision and all the stuff. Support open science and contribute to the digital single market. This is Europeanese. Okay, how to do that? Give Europe a global lead in research data management, and so on and so forth. So there are a lot of policy level motivations and objectives, and there are also a lot of scientific objectives, offer EU researchers the digital resources, and so on. So this is the big thing. This is a picture that is, obviously I won't go through it, and I won't read it, and I also don't understand its logic for the most part, but I want to establish pinpoint some of the keywords. Okay, it is people, data, and infrastructures. This is the main thing that is starting. We care about people, be it researchers or society, and so on and so forth. To do open science, you need data, and to support this, you need infrastructures. And then for people, you give open science. I'm forgetting the big things. The data have to be fair and open to industry. And infrastructures need to be federated. As I said, it won't be one place where everything goes. So it will be highly distributed, is highly distributed, and affecting society. And yes, there is such a thing, EOSC, it is being developed, but already it is available and someone can visit and play. And the word play is probably the right one. You cannot your science and your research cannot depend currently on EOSC as is. Individual pieces, yes, but not EOSC. And through the EOSC portal, the goal is, and you can visit this, as I said here, you can have, you can find your data, you can find publications, you can have policies and all that. And how do you approach open science with respect to the European Open Science Cloud, but also in general? This is interesting. We are in the United Europe. European Union is a subset of all this, and you can see very different colors in terms of the different speeds and the different levels of open science policies that we have. For example, here in Greece, we don't have a final policy from the government on how are we to do open science. And open science is a European mandate. Every single country in Europe, every research that is done, has to follow the open science principles. Of course, these are not, it's not a very strict rule. It's a framework, and every nation, every discipline may have variations within this framework. We in Greece, we don't have one, and several other countries don't. Others have some that are, yeah, okay, if you want it, and it's the first phase of the moon, and so you can do open, otherwise not. Others are very strict. So there is a polyphony and a multicolorism in terms of where every nation stands. So whichever country you work on, if you're funded from a publicly funded project, you have to be following the open science principles. You have to be looking at where the member state you're working in is with respect to its open science policy. A few things. What does this entail? We talked about publications and research data. A big thing is for publications, the intellectual property rights. Who has it? I mean, you have an invention. Who owns it? If you're open, presumably it should be open, but you cannot take advantage of it at all. And also a big thing, just having a publication and be able to read it and access it is okay, fine. The key thing is to give the opportunity in the context of fairness to mine the text, to allow the data sets and the text in a publication to be mined with machine learning models appropriately and so on, in order to identify and connect various terms, and also not just in one paper, but a body, a whole corpus of papers. For research data, a keyword that I want to emphasize is preservation. So you came up with data. How long do you keep it around? In principle, forever. But that's not in practice. You cannot do that in practice. When do you forget data? When do you summarize data? When do you don't do any of that and you keep it forever? So these are issues that are different from research to research, from discipline to discipline, and so on. And then practices. How do you what is your daily routine as you do research in the context of open science? So I won't go into this. You can read it, but a bunch of things here are not showing up when you do research, when you do science, not in an open science way. That's why all of us need to be reskilled, need to be trained a little bit on what we're supposed to do. And infrastructures like the European Open Science Cloud have a duty to train us and provide the appropriate tools and services so that all this is done easily. If a researcher, if one of you, in order to do open science, is requested to, well, send it to the journal to publish the paper, deposit it in the repository of your institution, because this is an institutional policy. Go to European Open Science Cloud. No, go to, let's say you're a biologist, or no, none of you is a biologist, but a climate science. Go to the infrastructure that does the CO2 measurements around the world, to deposit your publication and your data set there. And then also to do it in European Open Science Cloud. Obviously, you will not do any of this. The key thing is to do it once, and then whatever else it has to show, it to show. That's why there's a big weight on coming up with a correct European Open Science Cloud and its constituencies. Now we talked about publications and data. Let me give you a glimpse for the flow and what we mean by publications and data, just in case. So you do the research, you come up with the research results. When you do your research, you have to have from before, you have to be following a data management plan. What are you going to do with your data? In the past, you had it in your disk, in your computer, in your office. This is no more. Okay, and also you have to have a dissemination plan. In the past, you were sending it to a journal or a conference, and that was it. Now things are changing. After you have your results in this day and age, you have to decide how are you going to share it, and also whether you need to exploit it. Will you go for is there money to be made out of it? Exploitation in this sense. So decisions. Do you patent it? Do you form a company around it? Do you license it, and so on and so forth? That's why we don't talk about research alone anymore. It's research and innovation. So this is the innovation part. But then when you share it, two things: what do you do with a publication, if a publication is coming out, or what do you do with the research? And then publication, there are two ways to have open access to these publications: green and gold. I won't go into the details of that. I like green, the publishers like gold, and then the research data. Have it open, or in some cases, these data need to be restricted, cannot be open. There is the motto, open as possible, closed as necessary, because there are certain cases where the data cannot be open. I mentioned, like the private, you have a clinical study, it's a research study, it's private to the patient. Yes, the doctors or some researchers under certain conditions can look at this data, but it cannot be open, like the data of measuring, the atmosphere of Mars. Well, nobody cares. I mean, nobody cares in terms of privacy of that data. So all these decisions have to be made based on a data management plan that has to be predetermined. You cannot decide afterwards what you're going to do with the data. Because if you're done with your research, saying, oh, what am I going to do with my data in order to be compliant with open science, you realize that you will need a lot more of the data that you used in the past, you used in the course of your research that you forgot, you didn't keep, and so on. And let me say a few things about the word publication. I won't ask you, I know if I ask you, everyone will raise your hand on what is a publication. But when we talk about open access and open science, the publication is not anything that you write. When we talk about publication in open science, like in the other paradigms of science, we talk about peer-reviewed publication. The one that you send to a conference or a journal, and your peers in your community judge, and they say, okay, it's good, and it has to appear. Other types of publications exist, but when we talk about openness and the mandate to have open science and open access to these publications is the key thing is about the peer-reviewed publications. For example, you have a project that is funded. A deliverable of this project is not a publication. Although it may be restricted, it may this, that, depending on the rules of the project, it can be open or not. The publication, the actual added value that comes, the scientific added value that comes from the research, that publication needs to be open. And let me give you a schematic of some things that open science, how should I put it, supports. We have, okay, this is you or me or whoever. Anyway, you write the paper and you have a manuscript. We often, when I was your age, 500 years ago, we would print this and send it to some colleagues. What do you think of this? Okay. Now we can put it in a repository like archive or bioarchive if you are in bio, or there are others, disciplinary or general, and so on. So you can put it this preprint. Why would you do that? Well, I'm here, I've done it. The community can look at it. Okay. Open science is not talking about this though. It's in the same spirit, the same philosophy, but this is by definition open. Now the other thing is you send it for peer review, the paper is accepted, and now you have the final version. This can go into a repository, your institutional repository, some disciplinary repository, and so on. This usually is open as well, but still we don't want that. After this, you get the postprint, you get the version of record. This will be kept in posterity. 1,000 years ago, someone will go back and read your paper. That has to go to the repository, and this is what we call a publication. In the world of Facebook and TikTok and social media, where everyone, especially the younger you are, the more you do that, you spill out your guts for everyone to see, even this may cease to exist at some point. Not the peer review part, but this. And we can just have that. Or maybe we can have this, and then we can have open review. Whoever wants reads it, it's out there, and just by the same way you rate people or books in Amazon or taxi drivers in Uber and so on, then papers will be socially, scientifically, socially rated, and then that would be your review and the value of the paper. But I think we are a few years or a couple of decades away from something like this. But you can understand the difference between what we talk about. And bad examples, here we're talking about repository this, repository that, and so on. Here are a bunch of bad examples for repositories that don't give you what open access and open science means when they say open. ResearchGate, or having Google Scholar. ResearchGate, they're a little bit predatory. I don't like ResearchGate. Google Scholar, it's fine, it's open, they do it, but that's not a repository. Okay? It's just a metadata, an aggregator of metadata that offers a service to the world. Thank you, Google, for this. Okay? They've done an amazing job, 2.5 people, but it's not a repository where you publish. Your personal page or blog, okay? You can use this, you can do whatever you want, but that's not the publication. Websites, departmental, institutional, and so on and so forth. It's a different story to have a portal to a repository, an institutional repository. That's a different one from a web page. Preprint servers that don't accept postprints, Dropbox, and so on and so forth. All these are tools, useful tools, but that's not publication. So this is not to do any of this. This is not a publication. It's too huge. I should reduce it. It's too scary. Okay, I told you about publications, what is and what is not. let me touch up on the research data management cycle, which essentially, because most research nowadays is data-based, is essentially very close to what you do in your research as well, except for your thinking. Okay, traditional research starts with a hypothesis. Could this be true? More or less in all sciences, it's like this. And then you go and collect some data, some thinking. Okay, even mathematicians try a few things to see if the theorem will work, but forget the completely theoretical work, okay? And then you collect data, you process it based on somehow, maybe by hands, maybe by other ways, and then you store the data and the results, and then whatever is good, you preserve it, you publish and distribute, and then, since this is published and distributed, it's ready for reuse. And when you have a hypothesis, then you cite others, and then you go on. Of course, there are intermediate arrows, you can go back and so on and so forth. But this is what is happening. Let me say that because of the availability of data, more and more scientific efforts don't start from a hypothesis. They start from a data collection. They say, we have so many machines, so many instruments, powerful instruments. Let's collect, tons and tons of data. And we process it, we store it, we preserve it, we analyze it, and eventually we realize which hypothesis is true. It's not hypothesis, it is post-thesis. Okay, it's a result. You just mine and you swim in the data. Many start from here, many start from here, but the circle is easy. And now each one of these post-its around tell you what you have to do in order to go through the circle, to manage the data, to do your science when you're operating within the open science framework. And this requires training, as I said, because we haven't been trained to do this. This is the new, we're transitioning into open science. And again, what is data? This is again from some policy, this is from UCL. It's the data, including associated metadata. So if you say, oh, I used this data set and I produced that data set, and you don't give it metadata in order to be able to interpret how you get from A to B, it's useless. You cannot reuse it. You cannot reproduce it. Everything that you need to validate the result. And also sometimes you may need other data that you didn't use specifically, but as I said, for example, there can be the parameters of the instruments that you use. And in order to be able to do this, I think it's the third or fourth time I'm saying this, you need to have a data management plan. Before you start your research, you must have decided, you individually or the group or the project or the community, CERN has a data management plan for the Atlas experiment that 10,000 physicists and computer scientists and others decided on what they do before they put the first wire to operate. So you come up with a data management plan ahead of time, which of course on the way you may update. It's not cast in stone. And here is it. I mean, it's not rocket science, okay? But still you have to do it. Let me skip this. Now, I talked about the European Open Science Cloud, which involves many infrastructures coming together to provide the infrastructure that I mentioned that has all disciplines, supports open science. A key infrastructure there, for me, maybe the most important one, because this is a very biased opinion, because I have led that infrastructure at the European level, is OpenAIRE, which stands for Open Access Infrastructure for Research in Europe. Now, how do you do in open science research? I'll give you a few slides, because as you progress in your science and in your careers, open science will be more and more important, more and more mandatory in order to do that. So OpenAIRE is pan-European. You see the E in OpenAIRE was for Europe, that has many horizontal services for open access. Not just publications, but data and software and so on. It's distributed, so it takes data from many repositories. I'll show you a map, and just grabs the metadata, analyzes it, and then offers a way to go to all the data wherever it is. It's linked up at science because a graph, if you consider every publication or every data set or every software or every person as a node, you'll get a graph with hundreds of millions of nodes, but with no information. Okay, it's the linking that gives you what you need in order to do open science and in order to extract value and knowledge. And last but not least is that OpenAIRE brings in not only the scientists to train them, but also the librarians who are the custodians of the publications, they are custodians of the data sets in the modern era, and so on. Europe has funded it. It's a project, it's operated for more than 10 years, and then since 2008 and 2018, a legal entity, as I said, was formed to be the infrastructure that supports all this. And this is, I'm not sure how familiar you are with the framework programs of funding in Europe, but all this OpenAIRE started in 2007 when it was FP7, then Horizon 2020. The first part was publications and piloting the data. Now, in the second half, it was all data. EOSC was started in 2018 when OpenAIRE, the legal entity, was formed. And Horizon Europe, open science is the way we operate. How many of you are funded by a Horizon Europe project currently? Okay, so you, and how many of you are funded by national projects in your country? Okay, all right. So some of you are not funded, but this is fine. 2/3 you are in this situation. Well, both Horizon Europe at the European level project, but also, as I said, in many countries, the modus operandi is open science. So you have to be doing this. Well, it's services, the most important thing for researchers. Training in order to know how to do and how to be compliant with the open science principles, open science, open access, and so on. And then policies that are mostly for the governments and the institutions, not to the individual researcher. And as I said, there are repositories where you need to interact with that at the national level or the institutional level. They are thematic, the biologists, the environmentalists, and so on. And then there are also global. And you can have the social aspect, the people at all levels, but also the technology that is there. I'm a technologist, and when we started, I thought it was all about technology. A couple of years in, I realized that technology is the easy part. The human, the social interaction, the training, the learning, the ability to use this one term and all scientists from multiple disciplines to understand the same thing is the important challenge. These are the services of OpenAIRE. This is just as many colors just to show you how many services there are. The key, the jewel of the crown of OpenAIRE is the OpenAIRE research graph. And I'll just pinpoint the nodes and the connections in order to understand the richness and where you can get from this. So you talk about a research project, and the main thing that someone is thinking about is publication, is subtitle. But as I said, to do open science, publication is not enough. It's the least. No, I shouldn't say the least. Anyway, by far it's not enough. You need the data set, the software, other research product, or input in order to do this. That's a research product. But in the context of which organization did it happen? In the context of which community? What project funded it? What the funder, who was the funder, and what product, what program within which this project ran? What other data sources were collected in order to do this research? And organizations are the institutions, but also the people that form the communities. So if you want, for example, you have a project, you run a project, and a student and a young researcher you want to assess whether you want to hire them or not. You can go there and see, well, that person in what community belongs, what projects they were involved in, what papers they wrote, what data sets they used, and so on and so forth. I'm just giving you one example. Or you want to study and you want to see who else works in this area so that you can ask them a question or you can collaborate with them. Well, starting from the area, you can navigate and explore this graph. It's open, it's complete. Nothing like this exists in the world and is still being built. Every person appears there only once. Every paper appears only once. So it's all deduplicated, and it's much easier said than done. Tremendous difficulty in order to do this. Transparent, trusted. Okay. OpenAIRE is interacting with and collects data from 24 funding agencies. One is the European Commission. Some are not for profit, like the Wellcome Trust in the UK. A bunch of national, the Portuguese, the Belgian, the German, and so on and so forth, are using OpenAIRE for this. There are 78,000 data repositories, 3 million projects, 140 million publications, 275,000 pieces of software, and so on. So it is 4.5 billion links. That's where the knowledge is. It's a huge graph. More and more, it is starting to be used in more and more contexts beyond its original purpose. These are all the data sources. These are European infrastructures, thematic ones on environment. EPOS is environment for earthquakes and so on. These are repositories of individuals, of IDs for individual people, individual citations, and so on. Many European and international funders, the National Science Foundation of the US, repositories of software, private repositories, the Microsoft Academic Graph, which has stopped to exist and be supported a year ago. Well, OpenAIRE has harvested and captured it. La Referencia is from Latin America, is the one that brings everything together it follows the OpenAIRE paradigm for Latin American researchers. And they harvest OpenAIRE, we harvest OpenAIRE. So special reference to this. And another star of the show is Inodo. which is if you have a paper or a data set and you don't know where to put it because your institution doesn't have a repository and so on, Zenodo is there for you. And now this is the funny thing, not funny, interesting. Now OpenAIRE has deals even with private publishers, and we harvest all their papers to mine them. And then, of course, we don't keep the papers. The deal is that we destroy them. But OpenAIRE captures all the links, including those that have been published in a whole bunch of Springer, Elsevier, also ECM, the Association of Computing Machinery, and I had nothing to do with it in any particular way, and many others. So this is OpenAIRE and Open Science. It's a call for collaboration of all the scientific communities and policymakers towards this. And you are called to practice open science, to collaborate in the context of open science paradigm and using the open science infrastructures like OpenAIRE, European Open Science Cloud. A very quick, I told you I'll come back to the scientific, the Sustainable Development Goals, SDGs. Is there anyone who knows what SDGs are, the Sustainable Development Goals? Okay, not all of you. Well, in 2015, the United Nations said the way we operate this Earth is not sustainable. Eventually, we'll hit a wall. So it established 17 sustainable goals that will change to be achieved by 2030. They will not, but still, it's a noble goal. In order to make our life on Earth sustainable. And there are 17. Number 13, where is it? It's climate action. Since this a climate summer school. This is what we're experiencing these days, although today was better, not as hot. So what open science has done, this is one effort, one example that I'm telling you, is to take an analytics platform has been made, and Athena, the research center, has come up with a prototype on mining everything that is in OpenAIRE and seeing which publications are related to achieving which sustainable development goal. So that then, if someone is working on a sustainable development goal, to have the corpus of publications that are related to it. And so you take OpenAIRE, you also take the United Nations Bibliographic and Information System, which is a vocabulary for various terms related to United Nations efforts in general, but also specifically for SDGs. The usual machine learning pipeline in a good way. And then we come up with these connections, and then we have humans to check, sample check, and say, yeah, you are saying that this is related to this SDG, but this is not. So this effort, UNESCO is very excited about this. And you can see here we talk about research products, meaning not just publications, but also data sets and this and that. For each one of the 16 true sustainable development goals, number 17 is an effort to catch everything. So you can see lots and lots of things have been written that could be related to a particular sustainable development goal. These are not papers that say, oh, now I'll tell you something about this sustainable development. It's general research. So there is a lot of effort that can help scientists where they go. And climate, there is about 1.5 million research products that one can work on. If data was not open, if OpenAIRE didn't exist, this would not have been possible. Okay, this is the traditional thing. And also, we did the papers, and then the testing, the validation was on United Nations speeches. Given all the connections, let's take the speeches and see if it works. I won't bother you with this, blah, blah, blah. Overall, it was an 80% agreement, which is, given what we have, this is a very good result, and people can trust this. So these are a bunch of references that one can use. I'll finish with my new hat that, as the president of Democracy said, I have, being the president of Association of Computing Machinery, which this year celebrates 75 years of existence. How many of you are computer scientists by training? Okay, so how many of you are computational something training? Okay, what is your training then? Environmental science, pure environmental science. Okay, something else? Physics, okay. All right, environmental engineering. Civil engineering. Okay. All right, okay. Data scientists. But what is before? Data science is not a science yet. I mean, it's bringing together from other science. Okay, this is fine. ACM stands for Association for Computing Machinery. Okay, we have some half and half also, which is for, this is the front page of acm.org, advancing computing as a science and profession. So we see a world where computing helps solve tomorrow's problems, where we use our knowledge and skills to advance the profession and make a positive impact. This existed before I became president. Computing rules the world. There's nothing that can be done in this day and age without computing. So us computer scientists, computing professionals, telecommunicators, and so on, have a responsibility. And the thing is, tomorrow's problems, these are not computing problems. These are world problems, scientific problems, industrial problems, societal problems. So whatever your training is, if it comes and when you practice it, you need computation, you are interdisciplinary tango with computing. And ACM, which started as a purely computing profession, it has been expanding and will continue to expand quite a bit more in terms of interdisciplinary elements that don't come necessarily from training, but from the practice of the work. You are an environmental scientist, and then you do computational science in the environment or the climate or in geography and so on. So this is a mission. I won't read the whole thing. Global is one thing I want to emphasize. ACMA is not for American, although I'm only the second non-American, the fifth or sixth non-American president, and only the second non-American, non-UK. The organization is global. There are members in 193 countries. And I want to emphasize the word open, since this is the topic. And professional and ethical standards is something that we work on. As ACM expands, I think we need young members, not just the traditional computing people that are involved in computing, but also that work with computing. ACM needs it. And I think as ACM changes, it needs you. So check it out. And if it makes sense for you, join. And if you're still a student, you're a student membership or a professional membership. And there is a webinar for the 75th anniversary in Europe. You can check this out. So this is it. I want to thank you very much. Any questions you may have?
Thank you for the presentation. I have a quick question, I hope, because I can see you very optimistic, of course. But in your opinion, how much time it will take to arrive at a certain point where all articles or publications will be open access in a terms that I mean, today there are a lot of companies behind, and so they get a lot of money from these not public open access publications, and at the same times you also talk about the fundings from projects, but until the project are pending and the results from applications are not publishable, and so we need to see the end of the project before the publication, and when the time of publications arrive, there are no longer the fundings from the project. So there are still some limitations. So how much time do you think it will be before arriving to 100% open access, if it will be?
Okay, you said I'm optimistic. I was born optimistic, but now this is not by birth. My optimism here is not just by birth. Yeah, I don't quite remember the latest number, but I think currently of all publications that come up from European projects, is about 60% is open access. So we are already at a high level number. Also, there is pressure from the scientific communities for publicly funded research to be open. And when something is not working in this direction, some communities revolt. And the policymakers, the politicians, the governments have realized this. They see the value, and they have mandates. And so I'm very optimistic that by the end of this decade, let's put it this way, this is not too optimistic. I don't want to say by 2025, but for sure by 2030, everything will be open access if it is publicly funded, if not earlier. It will become, currently, although there are mandates, if you don't follow open science or open access, there's no true punishment. But now, little by little, there are discussions on how are you going to be assessed as individual, or as a university, or as a department, and so on, because there are assessment processes that are being discussed. And the tendency is you'll be assessed only on the things that you have open. You will be assessed also on how you follow the remaining open science principles, not just whether your publications are open. And then, next to the carrot of the democracy and the philosophy and the openness and so on, the stick will come, and I think this will solve that. Even private publishers, they realize that this is the way to go, and they come up with a whole bunch of, this is recorded, a whole bunch of approaches to take advantage of this, maintain their profits, and still give open access with access page fees being high, so the author pays, and sometimes outrageously high. Now, there is where the difference between gold and green open access is, that I didn't go into the details of that. And it's up to the governments to, and the communities to come up with the right policies and funding schemes so that the pricing becomes right and the prices are paid by the project. I'm not sure if this answered your first question before I go to the second one.
More or less, yes.
What is the less?
I mean, I was thinking, you said you were talking about the the governments that they are eligible, that after their term, they know what they said, I don't remember the specific word, but okay, we have governments that last between around 5 years, let's stay optimistic. And there are some governments that are in favor of research, publication, so on. But on the other end, there are some that are not. So those funds will not be available for the research community. This is what.
Okay, you're saying the funding will not be there.
Yeah.
As much.
Yeah.
This is a much more general problem than whether something will be open access or not. If they don't, if you fund a research project, let's say 100,000 euros, okay, some of this should be part. I mean, there are various schemes on how to do this, but one is I give you 100,000, 7,000 of this is for publishing, and it has to be open access. Okay, it's part of the budget. There are other schemes where the institution, from all the fundings, from the overhead that they keep, is for publishing, and it's not per project, it's per institution, sometimes even per country, depending on the country. Okay, so there are various schemes to do that. And a government that is not positive for research will not fund research as much. It's not the open access issue that will suffer. The entire research program will suffer. Let me answer her second question, which is a very valid. I mean, the devil is in the details, and this is a detail there. Europe, a few years back, ran a pilot program with OpenAIRE that said, we will give you, I can't remember now the amount, and for all the projects that are funded under Horizon 2020, for 2 years afterwards, they will be getting money if they're done and they are publishing results beyond the time frame of the project. They will be coming to you and you will be paying the open access fees. And it worked great. The pilot was successful. I don't know what policy will be instituted in that, but there are ways to do it because everyone understands that this is a true problem. You cannot be spending money after the end of the project. So some other way, like what I said, there will be a central thing at the university or I don't think at a country, or at a special project where you will be going and asking money for that. So there are solutions. What will be decided, I don't know. But it has been tried a few years back and it worked really great. I can't remember, I think 500, 600, 700 publications were in this category and they were paid this way. Yes.
Thank you.
Yeah, you. Yeah.
I have a quite of a kind of follow-up question. How, if open access is to become the gold standard and for also research evaluation, how to bridge the gap to the global south, where those values for open access publication are absurd. Like I'm also from Brazil, and basically the fee to publish in a medium level journal is the same as what I would receive for an entire year as a PhD student. So how could we find solutions to bridge this gap and allow global open access to be a global advantage and not only for the rich countries, if society is thinking.
Let me make sure I understood your question. I mean, because there are many gaps between global south and the most developed countries. You are saying how will publications from the global south be open?
Yes, basically, how can a researcher funded even in the global south would be able to pay for publishing in Nature?
Okay, I get it. I will tell you what ACM is doing, which is not, I mean, Nature is part of Springer and it's for profit. ACM is a not profit for profit. It is a publisher as a scholarly society at cost. The scheme that we are working on now, and we are in a 5-year plan to transform, is that the institutions, the universities, the research centers that publish the most, rank all institutions in the world. I don't know, 1,000, I think it's 1,500 universities and research centers and other organizations that publish with ACM, or could potentially publish. Maybe they haven't, but they are computer science departments and so on and so forth. And you rank them by how much each publishes. Okay. And then there are a few bands. And then the top, because they publish a lot, they pay that much, then the next less, then the next less, and then the next less. The goal is that half of them, the bottom half, will not be paying anything. Okay, I don't know if this will be achieved. And the top guys don't like this, but they kind of understand. So we're in the middle of this experiment. Most of the global south places are in the lower bands. And so with reduced rates that the institution will be paying, not the person, okay, the library of university of something will be paying, will be able then someone to have access to everything that is available. In addition to this, and as I said, we're in transition to that plan, but even currently, there are about 30 countries where they have much reduced rate to do that. All 30 are in Global South. Global South has more than 30 countries, but anyway, these are the 30 countries that people who studied this a few years back decided that they deserve the special treatment, much reduced rates. And yeah, these are the two. We won't achieve the goals, the high goals of open science until it's available, truly available for everyone. So that's.
Thank you.
Yeah, I have a final question. Thank you very much for the speech. So it seems like this notion of linked open data, as you call it, is crucial to the core of OpenAIRE in general. Correct. This huge graph of metadata and publications and the manuscript itself and the data sets and the code and funding schemes, etc., is crucial, and it makes sense. We can do a lot of data mining there to extract very important results. So my question is, do you think that this could also be used to define a new type of, let's say, impact factor per publication or even per data set? Because publications are already the result of some peer review process or something, while data sets lack any review in most of the cases, especially for machine learning. So do you think that this could be a great opportunity to produce something that is globally meaningful?
As I mentioned, assessment of research, be it of a research paper, a research data set, a researcher, a research institution, and so on and so forth, is now being reassessed, redesigned. And especially in Europe, there is an initiative that started from the European Commission to come up with a broad guidelines. And 300 and some institutions have signed to participate in this. Athena is one, Forth is another, I think the University of Thessaloniki is another. From Greece, as I said, from Europe, there are 300 and some institutions. And you need a very different approach. And one of the things is what I mentioned in the very beginning. The value of a paper, let's take a paper, traditional paper, should not be not associated, but derived from the value of the journal. It should be derived on its individual content. And by having the OpenAIRE research graph, where you have all the connections and the references and the who did what, and of course where it was published, and so on and so forth, and downloads and this and that if you want to use this, it gives you lots of tools to have a much more 360-degree approach to assessing a particular paper. The graph doesn't have any of the data sets or the publications. I mean, there are links to, as long as it's open, of course, it has where it resides, can reside anywhere. But all the analysis that has gone on in order to construct the graph offers tremendous knowledge about the value of the paper itself and its life on the way. So yes, the graph funding agencies of some of the 24 that I mentioned use the graph to see how well a project went. They use it to say, okay, we put that much money into this area. What came out of it in terms of data sets, in terms of papers, and so on and so forth? And if not much happened, then maybe we should not fund this area. So this information is valuable for many uses to come up with strategy or policy, or even to do work, to find what are the most important papers for you to read when you go into an area, and so on. So absolutely.
Thank you very much again.
Thank you very much. It was a pleasure.